I'm Haim. In the last 25 years, I am developing software for my living. And right now, I'm leading the backend development in Next Insurance, and also one of the organizers of Java.IL, the Israeli Java community. Next Insurance, before Next Insurance, I'm also the father of 2 teenage girls, so if you're thinking serverless is hard, try raising teenagers. I recommend it very much. And also I have a dog named Mushu after the dragon in the Mulan movie, and he also responds to the keyword Rakaris, so don't try it on him. So, Next Insurance is a startup aiming to revolutionize the small business insurance in the US. And we are on the road like almost 2 years. We started developing in the May 2016. And right now we have like 52 workers, part of it in the headquarters in Palo Alto and part in our offices in Kfar Saba. Our engineering is in Israel and we are hiring. As a startup, you have the privilege to try new technologies. So about a year ago, we started to use AWS Lambda. And I will give you a spoiler and will tell you that, same as in Game of Thrones, the end is bittersweet, okay? So, a bit of statistics. First of all, 5% of our code base is serving Lambda functions, which means about 10K lines of code out of 2,000K lines of code. We have 81 functions, part of them in stagings and part of them in production. 50 functions are developed in JVM Stack. We write our code in Kotlin. So the JVM Stack functions are based on Kotlin, and 31 Node.js functions. And we pay a huge amount of money to AWS for Lambda. It is $15 a month out of about $10,000 that we pay for the other AWS services, including $3,500 on EC2 services. So it is quite, what are we doing with AWS Lambda? 3 main usages. The first one is quite trivial. We use it as a system-wide cron for invoking microservices endpoints, okay? Just write a simple JavaScript functions that connected to CloudWatch, and every time the time passes and you get to the right time, it invokes. Okay, that's the simple solution, nothing to talk about here. The second one is one of the use cases that Amir was mentioning before, is like moving data around. Every time you need to take something and move it to some kind of a pipeline, we use Lambda for it. And the last one, which is, I think, a bit controversial, because I will go into more detail in it later, is a cheap alternative for microservices, and actually implementing business logic. So just a quick 2 examples of how we are moving data around. We are using Stripe for our payment mechanism. So we are charging customers using Stripe, and then we get Webhooks back into our system. And what we implemented is an API gateway, which takes the HTTP request, move it to a simple Lambda, which does a little bit of analyzing it and moving it to a payment service mechanism, which is inside our VPC. So it's like exposing an endpoint to the outside world. That's what we're doing with it. Very simple. A more complex scenario is when we want to take these webhooks and port them into the developer machines, like in dev environment. And then we don't want to expose every developer machine to the outside world. So what we have done is that we connected API gateway to a Lambda, which serializes the event, put it into Kinesis, and then the clients are connecting to Kinesis and pulling the data that is relevant to them. In that really simplified the way that we work as developers, and now we can get webhooks to our developer machines, okay? And it costs almost nothing. Let's go now to the business logic. We use Microservices Stack. We use Elastic Beanstalk as the deployment mechanism, as well as the load balancing and the high availability. So we are using Elastic Beanstalk to deploy our services, and we also have like 2 instances that are load balancing and having some kind of redundancy between them. And on top of Elastic Beanstalk, we're using Drop Wizard as our microservices container, which is some kind of an aggregator of technologies for the JVM stacks, which is giving also like REST API and database access, and also logging mechanism, and a very nice way to do configuration, okay? So all these services are something that we are getting for our microservices stack, and we develop our code in Kotlin based on that. And we have like 9 microservices that we have in our system, and additional several Node.js microservices as well. Logback is reporting to our ELK, which is currently logs.io, and database is RDS MySQL. So this unit is quite closed, and we know how to handle it, how to manage it, how to deploy it. We have CI pipeline and also continuous delivery. So what we saw that it costs a lot of money, okay? Every new microservice we want to introduce is a few $100s in addition to what we have now, because we need 2 machines for staging environment and 2 machines for production environment. And of course, we can improve it by adding Kubernetes and other schedulers that can reduce the pricing and use Docker, etc. But as we said before, we are a startup and quite early stage, so we are able to experiment. So we tried to model microservices as Lambda functions. We introduced a concept that, I don't know if you have a better name for it, go ahead, but I call it the module concept, which means that we group several functions together. We try to think it as a microservice and just shatter it to several functions, but all these functions are working together, deployed together, built together, share the same data store like a microservice, and deployed as a single jar. We like compile it together and create a jar that we deploy to several AWS Lambdas. This can be a quite large jar, like 30 megabytes, and there is a 50 megabytes of limit in AWS Lambda. So I don't know what we will do when we will get there, hopefully not. Oops. So on top of that, we try to give as much as possible services to this Lambda that it will think that we resemble the same mechanism that we have with microservices. So we give access to database, and we give a logging solution, and we give a configuration that is very similar to the concept of what happens in Drop Wizard. So I want to give an example. We are using it, for example, for something that we call the notification service, which send emails, SMS, open Zendesk tickets, and send snail mail emails. So it has several endpoints. Adding a new notification, send pending notification that either a retry or something that was scheduled for later time, and also ability to get the notification for a certain user and the details of a certain notification, including the content, okay? So 5 APIs that we could easily develop as a microservice are now deployed as 5 functions with the same code base, okay? Each one has a different entry point and connect to the same data store. We store the notifications that we send to the database, and when we want to retrieve them, we pick them with another AWS Lambda. How do we configure and provision Lambdas? We use Terraform, but there is a caveat here, because Terraform also wants to deploy the code. and we really don't like it. So we need to hack Terraform a little bit and ask him not to be aware to the fact that a code has been changed by the ignore changes, S3 key and last modified, meaning that if the code changes, Terraform will be not aware of that. So it's only handling for building the infrastructures around the Lambda. And we're using our continuous delivery pipelines, our regular continuous delivery pipeline, to do the code deployment. So we build the code, upload the jar to S3, and then invoke an AWS API to put it into the staging VPC-related Lambda. Okay, and we do it during the build of our system. And after we do that, we tag it. We give it tag staging and with the version, because it's not really easy to understand which version you're running with AWS Lambda unless you use the versioning mechanism of AWS Lambda, which we don't use. And later on, when we deploy to production, we take the same jar and deploy it to the relevant Lambda function in production. Logging, we are using logs.io appender, which means that the logs are going directly to logs.io and not to a log file. Okay? It's also written to the standard output, so you can watch it in the UI of Amazon, or the console. But basically just go directly from the service to logs.io. Initializing the logging is done on Lambda startup, and we keep it in a static variable, so it will be there as long as the Lambda is warmed up. Configuration. We are simulating the same mechanism of drop wizard configuration, meaning that we have a YAML file which corresponds to a Java bean working together, mapped one-to-one. So everything goes from the YAML file to the Java configuration. And one thing that we need to notice here that we have the enc XXXX, it means that we encrypt some of the data in our code. So we need to use KMS to decrypt it when the Lambda starts. So this is a very heavy lifting for cold Lambda. It can take several seconds. So as long as we are running it in a non-cold world, it's quite fast. But if we need to start from fresh and need to decrypt the configuration, it is taking several seconds. So basically, what we are doing is we are not using it for mission critical tasks, mostly asynchronous stuff like sending notifications or changing periodically the lifecycle and understanding what happens with our policies, or webhooks that we get from external services. So I would like to say that everything is perfect, but it is not. There are several open issues that we didn't solve yet. First of all, transaction tracing. We have very nice systems to do transaction tracing on microservices. We are using Zipkind, and also our logging carry out the transaction ID all over the system. We don't support it very well in our Lambda solution. We don't do any connection pooling right now. It doesn't really make sense to have a big connection pool for a Lambda, but maybe storing the connection to the database and reusing it when you are using a warm Lambda again and again. And we are not using the AWS versioning system, which I still trying to figure out how to introduce it into our system. And if we think about the pain points, so if we discussed before the notification service, we deployed it to production, it was really cool, and about 2 hours later, the storage on the Lambda device depleted. So it's stateless, but not really. And it turned out that the mail API that we use stored attachments in the TMP folder. As a result, we needed to delete the temp folder after we finish every invocation of the function, okay? So it is stateless, but you need to take care of stuff that from time to time you don't even think about it, like third parties that you use that write to the disk, etc. If we cross the 50 megabytes bar, we get into problems, and then we need to shrink our jars, and we're really close to it. The warm-up time is really disturbing. We need to find ways to improve it. I'm really bothered about code organization, because when you have like 6, 10 lambdas, it looks reasonable. But when it gets to hundreds and thousands, God help you. You cannot find your arms and legs. It's very hard to do it. It's very hard to do encapsulation with Lambda. And also code reuse. It seems like when you're using AWS Lambda, you're from time to time will be forgetting to do code reuse. And one more thing is that debugging is hard. Doing debugging for AWS Lambda is virtually impossible. So I think that the bottom line is that it is a very nice experience. From my perspective, it's still not very mature, although we are using it in production and we're using it successfully. But I'm having a lot of thoughts of what we can do better and how we can improve our mechanism. I hope that maybe someone hear this talk and afterwards give me some solutions to the problems that we have. But it is very cost effective for a company of our size and our load. It's tremendously cheaper than using any other mechanism in the cloud. Anyone have questions? Yes. Not for all function in the same module. Yeah. Conceptually, it's easier to think of it as a microservice, and then when you think of it as a microservice, like you put it on the same Java module, on the same hierarchy and structure of code, and it's like they're together, because if you put everything in a different place, you will get huge amount of places to put code, right? So it's like a designer decision, but maybe it's because I'm not thinking clearly, okay? You can also split them apart, but what makes it better when you have like putting in the same place, it's like you can configure the database together and you have the configuration together, and everything is the same place. And it's like putting them near to each other because they are very closely related to each other. Yes? The startup times or the warm-up time of AWS Lambda, when the Lambda is called, it can be like 5 seconds, mainly because we are decrypting the keys with KMS in order to get the configuration and the database keys to connect to. But after it is warm up, it's like 100, 200 milliseconds. It's okay for our users. Yes? Okay. It's a good question. I will repeat the question. It's how do you do upgrade of Lambdas when you have like dependencies? A Lambda depends on Lambda, etc. Right now, for our entire way we work, we're trying to work always in a backward and forward compatibility. So, yes. So for example, we expect something to get. We will change the signature in such a way that it will maintain backward compatibility. So if, for example, if you add to the JSON some kind of a key, it's okay. If you remove a key, you do it only after the usages don't use it anymore. If you want to rename a key, you add another one and then change it and then remove several deployments to achieve this. Yes. We don't go back, and we are enjoying the fact that our system is a little bit complex, but not very complex, okay? So right now it works for us. When we will need to improve our mechanism, we will do it. But right now we are always assuming compatibility when we move forward. Okay? Or take the site for a downtime and do whatever we need and fix it, but it is very rare. Okay. Thank you.
Thank you.